Hi everyone, this is a video going to be on mesh patterns. So to get started, I'm going to put a mesh plane on the canvas. If I zoom into this, I can see that it basically takes a rectangular boundary and then a width and a height that allows me to control the number of faces. So the boundary won't change with these sliders. Turn that down to something much smaller. So there. The boundary doesn't change there. So to get control of the boundary, I'm just going to use a rectangle. And I can use these to control the X and Y of the rectangle. And this rectangle will have its start on the origin. So there's X and Y. Put this, let's say, to 30, 30, and 10. Then I can also use an XYZ point, start point, at the start here, just to use the Z coordinate. This is going to be the base plane where it begins, this little green point here. So this can be the Z height. You can see out there how that will go up and down based on that. If I move them, this whole thing will just move on the X and the Y, but I'm fine with X and Y being 0 in this case. So looking inside the mesh there, I can sort of use a deconstruct mesh as one way to get access inside the mesh. And I can say I get access to the vertices, I get access to the faces, but they are as indexes of the list or indices of the list. So this is vertice 0, vertice 1, vertice 12, vertice 11, forming the first quad mesh. And if that was a tri-mesh, you would just see the 3 indexes there, not 4, per face. Then colors, there is no colors, but meshes can have a color on every single face if they want it. And normals. So this is point normals, because you can see there's 121 normals there, and there's 121 vertices where there's only 100 faces. So if I wanted access to the face normals, I would just use the face normals thing. You can see there that that is in the center. And if I was to do display vector or vector display, other way around, and I, on the center point, display those vectors, I can see what those vectors look like there on the faces. And if I change this to that one, I can see the point or the vertice normals, which are different. And so there's 121 of those and 100 of the other. Then I can also get access to the mesh edges, which is this one here with the quad. And that will give me specifically the naked edges here as E1. So you can see the edges around the edge, and gives me 40 of them. So if I wanted to do join curves, I would get one curve around the edge. And then this one here, which are 180 line-like curves where all of them are sort of separate edges. This one's probably going to be empty, which gives me edges with valence of 3 or higher. So then another one, just to explain all the ways that I can deconstruct this, naked vertices coming from Kangaroo. And this allows me to separate the points that are on border, naked, and the points that are in the center, clothed. So next I want to make a gradient for color. So I'm going to right click and change presets to just a rainbow. And what I want to do is I want to see the faces in order. So if you had the plugin, you could use Explode Mesh and that will give you the faces as separate meshes. If you don't have that mesh plugin, you can just use mesh. I think it's face boundary. Yeah, face boundaries. So face boundaries, this will give us a curve, and you could either do simple mesh from here or make it a surface. So now I have 100 meshes there. And I want to see these taking a color where I see the order that they're in, because I'm going to show you that different ways that we can manipulate the mesh might lose the order and where that order becomes important. So if I take these meshes and I want to do a series, and I'm going to use the series just to generate a list of numbers matching the indexes. So list length. It gives me the total number, which is 100. If I put that into the count, now I get the numbers 0 to 99, where that's 100 numbers. So I'm going to use that to give me the colors. The length is 100, L1, and L0 will be 0. So that means that the first thing on the list will take this color, then second, third, fourth, fifth, sixth, and then 100 will be up here. And so now if I do mesh colors, you could do custom preview as well. So mesh colors, and my matching number. This is 100 meshes, 100 colors. Let's just graph them both. Actually, that might be already working. That's probably not. Let's graph them both. I'm going to lock that and graphed. Yeah, unlock. There we go. Okay. So I can kind of see here that the order of the meshes is in order because the colors are kind of coming out as a sort of smooth gradient. And if I was to turn this up now, let's go with 30, 30. I can see that this is still in order. So I can make this into a group, and I can put any mesh in here and check whether it's in order with this as my output. So if I was to do quad remesh, and I take any mesh, so this is going to be my quad remesh, and I was to put this in here, and then I do Control Q to turn that off and see whether those faces are ordered. The answer is they're not, right? You kind of have some order here, and then they kind of change order and stuff. And the more I use quad remesh, I can see that it rarely ever gives me an order. So one thing I want to kind of learn how to do is to take a list, any list, and get them into order. So in this case, this one's quite easy because I can sort them all by the X, and I can sort them all by the Y. And if I guess, copy this here. Let's turn this off for a second. Okay, so let me get an area for each of these faces. And this is 2025 faces, and I know they're not in order from what happened here. So I can deconstruct the center point from area and then sort by X. Sort list, and You use the X values to sort, and then the A values are going to be my actual points. So now if I went through this list, I would expect this list to be points sorted in the X direction, probably this way, but not sorted in the other direction. And I've different ways of which I could separate those into rows. So I'm going to use partition list. And if I knew exactly how many were in a row, the partition would separate them into branches where they're on the row. But also I could just go back here to the original mesh and either, I'm not sure if this is a plugin or not, but mesh statistics, and get the number there. Let me just check this plugin. Yeah, I think that's coming from Parquet. Pufferfish. Okay. Let me just go deconstruct mesh. And get the list length for the total number of vertices. And that will give me that same number there, 2116. And then I can get the square root of that number. So this is because I know the square root of the total number of vertices is one row. And I see there's 46 in a row, and I can use that for the size of the partition. And now I'm separating all of these points into rows of 46. Then I can deconstruct this point again. And this time I want to sort by the Y. See, I have one extra point there than I want. So this. We just check the map here. Actually, sorry, I want to get the number. Yeah, that makes sense. I want to get the length of the number of faces, which is 2025, get the square root of that, which is the number of faces in each row, and then partition that list with that number. So that's the number of rows. So it's got a flattened list of points, and it's separating them into rows. And then now I've got all these Y points, but there are all the points, but getting the Y coordinates separated into each row as a separate branch. Okay, so now I can do a sort again, and sort list. And let me sort by the Y values. And I'm going to sort. Actually, I think rather than sort the center points, so this is the A going to sort, what I'm going to sort to match the pattern of K, I'm going to sort the actual polycurves themselves, and then get area again here. So I insert that in here. And then this is sorted into branches. I'm going to sort that. And hopefully then this is sorted in the X and sorted in the Y. So if I make simple meshes simple mesh of all of these, oh, this is all nulls. See what we have coming in there. So that is the points. So I want to sort the curves. We sort that, then get the centers. Centers go to there. That now is sorting the polylines, and then let's create a mesh where the polylines were. Okay, this makes sense now. And then I could join the meshes, or I could just put them directly in here to test whether they're in order. Making sense? Okay, so we can see that's in order by the gradient of color. And you can use this method to take an unsorted list and sort by X or sort by Y. In other shapes, it might be more complicated to do, but sometimes you have to sort of figure out a way to sort your unsorted geometry so that you can then get it in order. So if we take this output, which we don't need to like assign the colors, but we know that this mesh here is a sorted mesh. I'm going to basically drag this here and then now start to make mesh patterns from that. So I want access to the vertices, and I can do that with the deconstruct mesh. And I'm going to construct mesh as the end after I've manipulated some of these vertices. So if I just connect the vertices and faces, I'm not worried about the colors. I'm going to kind of make the gap here. And let's just do move unit Z, where we drop things down. Or actually, we could just use unit Z to move certain vertices down, or we could deconstruct the point, knowing that we've already, from the beginning, moved our mesh up to 5 in the Z. We could just deconstruct the vertices and reconstruct them. But drop the Z value. And see that it drops all of them down. But I don't want to do that with all of them. I want to only do that with some of them. So let's do list item and get a random of the vertices and get a random list of numbers to select the vertices. So the domain range for random numbers wants to be the length of these. So if I get list length, oh, actually, I should have joined this mesh, so it's one. I might weld it as well. this will join and weld a mesh, which means it'll get rid of any excess vertices. Okay, and then we're deconstructing, and okay, so we can get the list length here, and I think I don't need to create a domain. It'll just give me, so that's from the number 0 to 2116. I guess technically it should be one less than that, but that's fine. And number of random values. So I'm going to put a slider here. This is how many points will be moving in the end. And then I'm going to put the same on seed, which is just going to randomize the random selection. Okay, so select a random list of points and move those random list of points back to the 0. I could use project as well, or move a vertical distance. There's so many different ways I could move these points. And then I want to replace items, because I'm going to replace items from this list of vertices. So list of vertices, the items to replace with are the new set of points, and the indexes to replace them at are this random numbers that were used as the indices to select them in the first place. And now this is our new list of vertices, and I can see what happened there. So just turn off all the excess geometry. Okay, so seed will change which random vertices are being selected. Numbers how many random vertices I'm selecting. Now we've got less, and just move them around. So for this, it wouldn't really matter what order the mesh was in, because I'm just going to randomize the selection anyway. That way. So let's say I wanted to do this again. Both of these. So do this again, but this time I want to use a dispatch and get a pattern that goes through all of our vertices and uses true false to select them. And then I'm going to weave. So when I separate them with some pattern of true false statements, and this is going to put them back together. And if I was to, I'm going to use move on this one, so that I can control the distance with a slider in the unit Z direction. And let me turn this off. So you see what happens when I'm selecting every second one and moving it. So to make a dispatch pattern to make a slider so I can change the number of true and false statements, I can just use two series components. That's the first one, the second one. The first starting number is what numbers first is each of these series going to begin with. And I want one to be 0 and one to be 1. Then the step, because I'm looking for the same number again and again and again, the step should be 0. So it's if it generates a second, third, fourth number, it's not going to actually increase the amount, which means it's either going to give me a whole bunch of zeros on this one or a whole bunch of ones on this one. And then let's do 1 less than 20 for slider between 1 and 20. And let's do number and put both of these in here with holding down shift. And now if I just look before I connect it, look at what I've done here. So there's my 0 and 1. This will increase the number of ones I generate. This will increase the number of zeros. And if I use this zeros and ones as false and true, then I connect that to that. And I can see how I can change this pattern. Now this pattern is clearly not linked in the correct way. And very likely, or almost certainly, because of the weave pattern here. So sometimes you need to reverse this order. Or even, sorry, the weave pattern was the same with the default, but now I'm using this weave pattern. So first thing I need to do is set the same weave pattern. So now this weave pattern is, say, the way they are dispatched and the way they are put back together again. They still need this reverse though, because this is 0, 1, and depends on how you connect it. But anyway, I just mess around with it until it works. And I can see that it is working. So now this is changing how many zeros are in the list and how many ones. And if I turn off these points, sometimes at the end, it's easier to see things with shadows when you do custom preview. So I'm going to put custom preview on the end here and turn off the mesh and then put a swatch. Color swatch. Okay. So this is the Z height of our extrusion. This is going to control the pattern for number of zeros, and this is going to control the number of ones. Okay. So what's much easier to do is to dispatch the faces, because if I want to use again a dispatch pattern of getting A and B, but I want to get rid of B, I can just copy this for, again, my zeros and ones. I'll do it down here. So this is separating the faces now in zeros and ones. And this is the faces that are going to continue to the next one. And now I can use this to go through the list of faces and use true false statements to turn off and on various faces. So at the end here, I might just add in a smoothing way, and you can do smooth mesh, Camel Clark, various options. Let's do Camel Clark. Go there. And now let's turn up our density. Let's go to maybe 60. Actually, because we're remeshing it with this number here, this is what's actually controlling it. So if we make this 4,000, then we would increase the density of our mesh. Yeah, there we go. That increased. Even 5,000. Okay, so let's move around this again to get. I can make it smoother here by turning this to 2 or 3. I wonder if I change this to ghosted, even rendered. So you can kind of see how that pattern is now looking. But basically, you can use this kind of method to go through any mesh and sort of cause some form of displacement using a pattern of zeros and ones. Now, this side, because it's going through with zeros and ones, it really matters that your mesh was ordered in the first place. So this is why I went to such an effort to show you how to reorder a mesh to make sure the faces are in order, because if they're completely not in order, then going through the mesh faces true, false, true, false, true, false, it's just going to create some random pattern if the mesh faces were in a random order to begin with. But if they were in perfect order to begin with, then going through them and going true, true, false, true, true, false, true, true, false, true, true, false will create a pattern like this where it's sort of repeating itself. So that's that part. And then in the file, I'm just going to copy in 2 alternative ways that we could have done this. I'll share afterwards. You can kind of go through if you want. So I'm going to do Control and Shift and V so that it pastes into the right place. So this, if I connect my mesh to here, I turn this on, back to ghosted. So this is randomly selecting vertices, but then also creating these circles that really are at a different scale. So from my list of vertices, I'm selecting random numbers, making sure they're integers. And the random numbers that I selected are the vertices where these green X's are. And then creating circles with a radius of 1 there. Then going back to the vertices and checking any vertices that are inside these circles. And if they are inside these circles, then saying equals to 2, which if I look here, the point region relationship, 0 is outside, 1 is on the curve, and 2 is inside. So 2 is here is saying, is the point inside the curve or inside the circle? And if they are inside the circle, then moving it in the Z direction by 10. And then this is the replace items to go back to right. This is to get the series, just to know the indexes of what where they should be replaced. Then we generate the mesh. So benefit of this is I can use circles to move down quite a number of points at any one time. And if I did random radiuses to the circles, I would sort of vary this again. But that's one script of just a different way of moving vertices in sort of groups. And it could be like the movement was based on the distance to the center point. So that if this was the center point, that this would move the most, then this one by 0.9 of whatever this one moves, 0.8, 0.7, 0.6, 0.5 to 0.3. And then you get a gradient of movement from the center point of these circles, called kind of a soft move, doing it manually. Going back, I'm going to copy in another example here. So this is surface manipulation. And let me turn this off. Remove this off. So just want to move this. So what's happening here is we can kind of use this to kind of almost move the mesh vertices like kind of water or like a surface. And if we go through it, basically getting the list, getting the random list of vertices. So if I turn this on and see this is the random vertices that I'm getting, and same as before, getting the circles, which are massive in this case. So they can see now that's the circles there. It's probably way too many of them as well. But basically adding this graph mapper to scatter the points. So only the ones that are inside the circle are going to move with the sort of wave pattern as I move this graph mapper. The rest is the same. I mean, basically, this is just an evolved version of this. So you wouldn't necessarily need to do the circle command. You could just apply the graph mapper to all of the vertices and two. And that's kind of it. Here's 4 different ways to apply patterns to the mesh by manipulating them. So definitely play around with bit faces and vertices and just how you can make patterns to move them around. I think this is what I kind of mainly wanted to focus on, is both using faces and vertices and patterns to cull some faces and to move some vertices. All right. See you next class.